Hello, this is question 23 of the 2016 ECAA paper. So, in this question, we're told that the first three terms of a geometric series are equal to the first, fifth, and sixth terms, respectively, of an arithmetic series. And given that the terms in the geometric series are all different, we're asked to find the common ratio. Okay, so remember we have these formulas for the nth term of a geometric and arithmetic series. So we can use these to work out the first, second, third, and the first, fifth, and sixth terms of these two series. Okay, so if we substitute n equals 1, 2, and 3 into this formula here to give us the first three terms in terms of the first term a and the common ratio r, and we can also substitute n equals 1, 5, and 6 into this here. We'll get the first, fifth, and sixth terms in terms of the first term a and the common difference d. Okay, so if we put these equal to each other, like they say up here, then the first terms are the same. I probably shouldn't have used a in here as well, but in this particular case, a is the same a. And also if we put these two equal, we have this here. And we don't care at all what d is, so let's eliminate that first. Okay, so here I've just multiplied this first line by 5 and this second line by 4. Then we can rearrange both these equations to make them equal to 20d. So we end up with something like this here. And okay, let me rewrite without the 20d in the middle. So we have this equality, and we can see quite nicely that all the a's cancel, so that's quite nice. So after we cancel the a's, we have this, and it's basically quadratic in R. So now we just need to solve this quadratic however you like. But I think it should factorize. So we need something that multiplies to make 4, so 4 times 1, and it needs to add together to make minus 5. So minus 4 and minus 1 should work. So if I just rewrite splitting this minus 5r into minus 4r minus r, and then I can factorize a 4r out of these first two terms and minus 1 out of these last two, and now r minus 1 factorizes out of this whole thing here. So we're left with this, and now we can see that either r is a quarter or r is equal to 1. But remember, we were told at the very beginning that the terms in the geometric series are all different. And if we had a common ratio of 1, if for each term we're just multiplying by 1 each time, that's not going to change the terms. If we had 1, then all the terms would end up being the same. So we've got to take the other route, i.e. 1/4. So that is d.